Hey, this is Rick, and this is another game development tutorial using the TypeScript programming language. If you're not familiar with TypeScript, but are familiar with JavaScript, basically TypeScript is the future of JavaScript in the sense that it is what will be JavaScript a few years from now. So TypeScript is a compiler that allows you to use features in in JavaScript that aren't widely available on browsers yet, like classes and enumerations, interfaces, things like that. And anyway, I've been using that to do some game development recently, so I'm doing this TypeScript game development tutorial on texture atlases. So if you've seen the previous tutorial on drawing an image to canvas, I'm going to start from that point. But if not, this is the rendering image to canvas tutorial. You can find it on YouTube in my channel, or you can go to typescriptgames.com/image-to-canvas.html or goo.gl L56 capital C FG. So either one of those, if you want to check out, that is what the starting point we're going to start from today as we're jumping into this. So, in that we had set up our game loop and our keyboard input, and in our game loop, where's my game loop? All right, so we were just drawing this image to the canvas. We were grabbing an image, this ship.png image file, and we were just drawing it to the canvas, and we were allowing the user to move it around with the arrow keys. So nothing too significant there. But now we're going to cover texture atlases, which are sometimes called sprite sheets. Although technically a sprite sheet is a slightly different thing. What I've been told, because I used to call them sprite sheets all the time, I've been told that a sprite sheet is basically for one character. So if you're writing a game, you'd have a sprite sheet for Mario, let's say, and then you'd have a different sprite sheet for Bowser, or a different sprite sheet for Toad, or what have you, if you were writing a Nintendo game. Whereas a texture atlas, I guess, is a more generic sort of thing. But anyway, sometimes I call them sprite sheets. If I do, then just know that I mean the same thing and I use them interchangeably. But for right now, we just have this image. But what we're going to do, if you're not familiar with exactly what a sprite sheet is, a sprite sheet is something like a combination of an image that has lots of different images in them. This tool is called Texture Packer, and I think it's like $20. You don't have to use it. You could put your own texture atlases together, but it's kind of nice. It packs them in there nice and tightly. But a texture atlas is basically like this image that's got all these other images inside of it, and it's usually accompanied by some other file, like this is a JSON file. It can be accompanied by XML, but we're going to stick with JSON. That basically says where everything is. So it tells you in this the name of the file you originally put in, this asteroid00.png, and within that where that frame is located. So within that image file. So asteroid00.png will be at x212, y152, and 01. This one is actually asteroid01.png. So it's located over here. I think I manually edited this to fix that, because I had it numbered from 1 to 36, I think, and I really needed it numbered from 0 to 35 or something along those lines. I needed it to start out with 0, so I think I moved this guy and manually edited it. But it's just a text file. You can put it together with Texture Packer if you like, or you could put it together yourself. It doesn't matter. All you need to do is know where those images are, within your file, and what basically within your image file, and where that is located, in here. So here's an example of the JSON that is created by Texture Packer, and I'm using this format. You can change it. You could do it yourself. Whatever. I might actually even put together a tool that generates the JSON file for you, and and the packed images, all in one. So I'll be working on that, but it's not going to be as good as, say, a tool that you purchase, because I plan on doing kind of a real simple version of it where it doesn't do the best job of packing, but just for anybody who doesn't want to pay for it, but at the same time doesn't want to do it all by hand. But you could really go either way. So anyway, if we look back at our ship, we had this image ship.png, and we had it set to display none, so it wouldn't show up. And then we were just going and loading that guy in our Windows on load. So we had our image loaded with a get element by ID. Not loaded, but we pulled it out of the DOM. So we grabbed this image out of the DOM with the get element by ID, and then later on we take that image and we rendered it to the canvas in the game loop. So that just used a draw image. And if you remember, I said, okay, this part here, this is really used, the offset and the widths, this is used so that you could tell it what parts you want out of something like an atlas. So you would use an atlas for a game that had more than, say, 5 or 10 different images in it. Like if you're making a very simple game, you could just use images within the DOM and it won't be a problem. But let's say you have a game out there with 500, 1,000 different images in it, which, wouldn't be a super huge game, but, would be something, that you might make for the web potentially. And you wouldn't want to put those in, their own individual files, particularly if they were small. You'd want to pack them into one big texture, one big image file, and then just take the pieces out. And that way, when you're loading your web page, it will load a lot faster, because if you have all those individual images, the web browser will actually make a request for each one of those images, one at a time. And so it can only hold so many connections. So, overall, you're going to get a much faster load if you use a texture map. It makes things slightly more complicated if you use a texture atlas, but it is worth it if you're doing a lot of images. So instead of this image, I'm still going to need to create an image out here, but this time I want to use atlas.png is what I believe I named it. So let me just see what happens if I run this. It should make this big. Yeah, see there, the whole atlas is getting loaded, where just that ship was getting loaded before. And this isn't a huge atlas or anything. This is fairly small, but we're going to have this animated asteroid when we do animated sprites in the next tutorial. So, I threw those in there, as well as the ship and the background. I'm not even using all of these things for this tutorial. I might use them in a later tutorial. I'm definitely using the animated asteroid, as you can see, in the next tutorial, but not in this one. So anyway, back to the code. All right, so now we have this atlas PNG, and I'm going to give it a different ID. What ID did I use for this guy? Yeah, actually, I'm not even going to need to do this. You can do it this way, but I'm actually going to have my texture atlas code load this guy directly. So let me go get, I created a texture atlas class, and I'm going to pull that guy in, and I'm going to explain it, what's going on with it. And it actually, it won't use a tag like we had before. It'll actually dynamically load the image when we make that request. So here was our keyboard input class. I discussed that in a previous tutorial. And underneath that, I'm going to put the texture atlas. All right, so let me step through. Oh, I also need a rectangle class, because these frames are all basically rectangles within. Yeah, they're basically just, everything has got to be a rectangle. Like, you need to know where that image is, what the bounding rectangle within your texture atlas is that has it. So we have this we have this rectangle, and it's just got x, y, width, and height. And you create it in a constructor, and then you could set the x and y values here. Let's see. I don't think I need this within or this set x. I'm going to get rid of these guys because I don't think I need them. They seem like they were code that I was using from before. So this is a real basic rectangle. It's got an x coordinate, a y coordinate, a width, and a height, and that will define where in your texture atlas, each individual frame is. So this is a dictionary that I've created here, and it basically is going to, you can use it to look up a frame from the name of the file. And what we're going to do is we're going to load into this, when we load up our JSON file, and let me go open my JSON file again. We're going to load it up, and this is going to be the index that we're going to use. It's going to be the name here, like asteroid01.png or asteroid02.png, or if we go down further, I think I've got like a ship in here somewhere, starfield.png. These are going to be the things that we're going to use to reference where that frame is. And here's the frame, and if you see this frame is a rectangle, and it's got an x and y coordinate within our texture atlas, as well as a width and a height that we need to use. So we've got this rectangle, and we are creating for each frame, when we load the JSON, we're going to create an index given the file name within that we had used to generate our texture atlas, and the rectangle that will tell us its location within the atlas. So there's going to be an image element, and we could have set this, by pulling it out of the DOM, but I decided not to do this. This is this is just a Boolean flag here that tells us, have we completed the loading of this atlas? And our atlas is going to have a name, which will be the name of the file. It's something like atlas.png, I believe. And then we have some private variables like the image file, the JSON file, and a private function that's a callback if you want some function to be called whenever the texture atlas is done loading. So here in our constructor, what we're doing is we're taking the atlas name, and the atlas name is also going to be the image file name. For a while I had something in here that was like image file name plus quote .png, and you could do something like that. So if you wanted this to just be atlas and you didn't want it to tell you, what the PNG file name was, you could do it that way, and then the image file would, be separate from the atlas name. But anyway, I just kept it, I switched it back to just having it, pass in .png on the end. So here's the JSON file, which, is going to take that PNG and replace it with JSON, because the name of our JSON file is going to be atlas.json. So you don't have to have it this way. I don't know of a better way to do it, but I tend to like to name the JSON file the same thing as the PNG file, except with a JSON extension. That way I could just say, all right, load whatever I want the atlas to be called, and it'll grab the PNG file, and then it'll grab the JSON file that has that same name, and that way I know that those two are associated. And then it's setting this load callback that's going to get called once the JSON is loaded, and then it's going to call load JSON. So to load the JSON file, we're actually going to do an XML HTTP request. I found this very confusing because, why do I need to request XML if I'm loading JSON? But apparently there's a whole history in JavaScript where initially people kind of hacked this XML HTTP request to load whatever files they wanted to, and so it the XHR kind of became the de facto way to just load files into your JavaScript, even though it's called XML HTTP request. Why they didn't rename it, I don't know. Maybe just for backward compatibility, but even though this is called XML HTTP request, we're going to be using it to load JSON. So then you take your XHR and you say, okay, when this is ready, we're going to run this function. So this guy is going to get triggered. This function here is going to get triggered whenever we have this on ready state change happens, which will be when it's finished loading. And then we're going to do an XHR open and use a get to grab our JSON file. And then, the XHR send will actually, do it. So then this guy is going to get called as soon as that's done loading. And it's going to check the ready state, and see is everything loaded appropriately, checking the status and whatnot. And then, we're going to use image on load, because the next thing we're going to do after we've loaded the JSON file is we're going to have to load the image file. So, here we're setting the onload function that's going to be called, which is defined further down. And we're also setting, what do you do if it errors out? And then this here will actually, start running the load, which, will take your image and it'll set the source equal to your image file name. And then that will be kicked off in the background while we go ahead and actually read our JSON. So then we call this onRead, that's actually going through and reading the JSON. And it's passing in our response text from the XHR request that we had above there. So that's coming in as, this data any. And it's it's coming in and it's got this temp frame, which is going to go into our whole frame rectangle indexed dictionary variable that we created up above. So we're going to loop over frame name inside data.frames, or loop over data.frames, and we're going to stick whatever value that is. This is going to be an any also into this frame name. And then inside that, we're going to have to grab the frame name and set the sprite data, this sprite data variable, it's another any, is going to be set to that. So if you're not familiar with how JSON, like loading JSON into JavaScript works, it's basically just treating each one of these guys as if they're like a variable. So this is, the variable name, and here are the values within there. So, if you look at this, we're going into data.frames, which is this guy, and it wants you to loop through every single, child node within data.frames. Data is just our variable that represents the whole JSON file. So, then we're going to have key value pairs, from there. So we'll have this, asteroid00.png will basically give you all of this data. So, we're going in and, we're going through and we're saying, okay, first get the frame name, which is going to be asteroid00.png, and then get all of the data that's associated with that frame name, which will be all of this, and then we're going to create a new rectangle that's going to have frame.x, frame.y, frame.w, frame.h passed into that rectangle, which will just be this x, y, w for width, h for height, and that's going to create our rectangle. Oops, scrolling up. And all of that is going to be put into our frames dictionary under the frame name. So inside our dictionary now will be asteroid00.png with an x value of 212, a y value of 152, a width of 52, and then a height of 50. So then it's going to go down to the next one, and it's going to create, once it goes through this loop a second time, it's going to create another frame called asteroid01.png that's going to have an x of 2 and a y of 2 and a w of 52, or width of 52 and a height of 50. And then it's going to go through and it's going to create all of those dictionary entries. And all we're looking at right now is this rectangle, this rectangle that'll be created by this frame, and associating that with a frame name. Okay, so the next thing we do, this gets done before the image is loaded, because the image load is going to take a little while. And then this on image load is going to get called once this image that we grabbed up here actually gets loaded. So then on image load is going to just basically set the TA load complete, which stands for texture atlas load complete, to true, so that we know that the texture is loaded, and then it's going to call the load callback. Well, we have to know what that load callback is going to be. We have to see where we created this texture atlas. So let's see. I don't have that in there yet. So now that we've defined our texture atlas, let me see. What do we need to do next? Okay, I actually need to add in. I need to define a variable called atlas. I'm not sure where I'm going to put that just yet. Oh, here. I know where I'm going to put it. All right. So let me scroll down here. And let's just paste this variable atlas in here. So we've defined this variable atlas that's a texture atlas. And now, inside of our onload, we're going to want to create a new texture atlas. And this game loop is going to be the callback. Now, we normally call we used to call the game loop right here as soon as the window finished loading. But now we can't do that because this texture atlas isn't loaded yet, even though the rest of the web page has finished loading. So now we have to get rid of this game loop call down here. So when the window's done loading, we're still not calling that game loop yet. We have to wait to call the game loop until this texture atlas has finished loading. And it's going to have to load both the JSON file. It's going to load the JSON file first, and then it's going to load the image. And it's not until that image is finished loading that the game loop's going to be called. So now that we're up here, we don't have this image anymore. In fact, I can just get rid of this. We don't need that guy anymore. So in our game loop, we're not gonna want to draw him. And if you remember, this basically part is telling it to just draw the whole image. Well, now we don't want to draw the whole image. We want to just draw part of the image, and we want to draw part of our atlas. So let me grab the code. All right. So we're just going to draw a single image from this guy. I mean, we could draw lots of images from this. Like if we wanted to, well, maybe I will in a second. So, all right, let's just start out, with this. And what we're doing is we're drawing this guy and this atlas image, but we're not saying draw the whole thing. We're saying draw the part that starts at this x coordinate and starts at this y coordinate. And those we're grabbing out of our frames. Remember how we loaded up those frames? That frames, if we go back to our texture atlas, get rid of you. Where did I put the texture atlas? If we go back to our texture atlas, remember I talked about this dictionary? So that string that we're passing in right there is like this guy. It's one of these, right? And then it's going to get back a rectangle, that is represented by this x, y, w, and h coordinate right here. So these values that are loaded in, they're going to be loaded into this frames dictionary in our texture atlas, and those are the values we're going to get out of it. Once I go back to my game loop. All right, so asteroid01.png. That is this right here, and this x value is going to be that in frames, and this y value, atlas.frames asteroid01.png is going to be this value, and then we have the width and the height. So this part down here is going to be for offset. We're not yet using this. When I do animations later, I'll get into, what these values mean here. But for right now, this is all you need to do. And let's give this a try and see if it's actually rendering something. Okay, so we're rendering an asteroid out of that. Let's just see what we could do to add a ship to this. Like we'll add the ship. I think I have a ship in here. Let me look. What did I call it? Mercenary 01 dot. I'm going to rename that because I don't really want that. Well, no, I won't rename it. Okay, so this was the name of our spaceship in there. So let me just duplicate this guy. we're just going to draw this a little further down. Actually, you know, no, yeah, we'll draw this a little further down. So we'll translate that an additional 150 pixels. Now, if you're not, this isn't going to be rendering it at 150, 150. This is actually going to be rendering it 150 pixels to the right and 150 pixels below where the asteroid is rendered. And the reason is we're not doing a context save and restore. I could just have that rendering at a fixed spot, but you know, I'm going to do it this way. And I'm just going to demonstrate so if this works as I'm expecting it to, we're going to have our asteroid rendered, and then we're going to have down and to the right a ship, a little spaceship also being rendered. Okay, so now we can move both of those at the same time. Now I can set this up so that you can move, you know, one with some keys and one with a different key. You know, and in reality, you'd probably want the asteroid to move kind of on its own wherever. Just for grins, I'm going to restore and save right here. And that way, like if I do this, the ship will always be at position 150, 150. Because if you remember what I said in my previous, you know, tutorial about rendering to the canvas, you're really kind of moving and repositioning the canvas, then rendering, you know, an object in whatever location, and then you're moving the canvas again. So if I do this, this ship will just stay put at 150 by 150, and I can move the asteroid around. You know. Okay, so that is about all there is to texture atlases right now. In my next tutorial, I'm going to show you what you need to do to create an animated sprite with a texture atlas. Plus, it would be nice to not have to do this, you know, maybe to have these guys in their own classes as opposed to, like, you know, drawing all of this out. And I talked about that in some of my earlier tutorials, you know, when you're creating objects. Normally you wouldn't want, you know, to do your draw image directly in your game loop. You would want each individual game object to draw itself. And that way you can kind of encapsulate all this stuff, and you don't have like a million of these different draw image calls, you know, all throughout that, and the translates. It gets kind of ugly. So, you know, you wouldn't, when we get a little further, we won't be doing it quite this way. And in the next one, we're going to create an animated sprite that we can use, that will go through and render, you know, maybe this asteroid, you know, being animated, and you know, and other things. So, all right, well, I hope you liked it, and please subscribe. And if you want to let me know what you think, what I could do better, what I could change, or if you just have questions, things you weren't clear on, I'm at TypeScript Games on Twitter. So feel free to send me a message that way, or just send me a message on YouTube. Thanks, and once again, please subscribe.